Hello everyone, my name is Zhongyi. Today I will present our work, InstructPipe, generating visual box pipelines with human instructions and LLM. The authors of this paper include Zhongyi, Jing, Vrushank, Xiuxiu, Jing, Xun, Kristen, Mark, Jason, Jingtao, Yiyi, Zheng, Yinda, Johnny, Alex, David, Ram, Na, and Ruofei. I believe many of us are using this kind of interface to write programs. Basically, what we're doing is that we write some text that define how computers should operate, and that's the programming process. However, instead of writing program or do programming by writing text, we can also do visual programming. That is, we can think about the program in a more visual way. And here's an example. So in this example, user selecting different kinds of nodes. And then they may need to connect different kind of nodes to create a pipeline. Sometimes they need to define and change some configuration of the nodes. And this, after a while, it will create a whole pipeline. In this example, the user is creating an image generation pipeline. So as you can tell from this example, there's a pretty common phenomenon. That is, we usually require visual programmer to programming from scratch. That is, we provide users with an empty workspace and they need to select nodes and choose nodes and connect the nodes. Sometimes it doesn't correct, and then we do a lot of debugging. And after a while, it creates a pipeline that is ready to use. And this kind of process time consuming, especially for beginner level programmers. They may be not quite familiar with the systems. However, on the other hand, which is the text-based programming UI, these days we have AI assistants. That is, users sometimes don't really need to write everything from scratch. They just need to describe what kind of function they want and to AI, and AI is going to generate a large portion of the code for them. Therefore, we will raise this research question that motivates this work. That is, how can we build an AI assistant for visual programmers? And that's what we build. So in this example, we'll just showcase how users can use InstructPipe system. So basically, user can write a prompt that describe what kind of pipeline they want to create and click submit. Our systems generate the whole pipeline for them. And user may sometimes need to do some edits on the programming interface using the standard visual programming process, and the pipeline will be ready to use. And this is a very good virtual try-on pipeline. So how do we achieve this? First of all, we would like to clarify what's the input and output of our InstructPipe system. The input is that the user needs to describe what kind of pipeline they want to create. And then we will take this as input and generate the whole pipeline for them. So how we achieve this? We achieve this through a multi-step processing design. So basically in the step one, we first create an LM module, what we call node selector. That is given users prompt, we're going to select a small portion of node that is going to be useful for creating a pipeline that satisfies users' needs. And the second step, we have another LM module called code writer that is taking users prompt as input and also the narrow down node library as input. The code writer is going to generate the pseudocode using the given nodes that describe what kind of visual programming pipeline they want to create. And step three is the code interpreter. That is taking the pseudocode generated from the previous step as input and render the pipeline on our visual programming UI. So here example, basically on the left side, it shows an example of pseudocode, and the right side shows the corresponding rendered visual programming pipeline. So there's two lines in the input section. That's why we have two input nodes, and we have one output nodes and two processor nodes. And the pseudocodes provide enough information for us to create this kind of graphic structure of a visual programming pipeline. Together, this figure just summarizes the whole workflows of our system. So InstructPipe takes user's prompt as input, and we have two LLM module to write the pseudocodes, and we have another code interpreter to interpret the generated pseudocodes and render them into a visual programming pipeline. To evaluate our systems, we conduct two studies. One is the technical evaluation, in which we organize a workshop where we collect 23 participants. We recruit 23 participants and collect 48 pipelines. We also have two annotators to annotate the corresponding the pipelines into different instructions. And in our evaluations, we take the instructions as input and predict generate a pipeline as a prediction, and then we compare the prediction with the ground truth pipeline, and then to see what's the number of user interaction that user need to perform to change the prediction into ground truth, and the number of interaction including user operations like add one node and connect one nodes. So the results show that compared with generating or creating a visual programming pipeline from scratch, our system is able to reduce the number of user interaction by 81.1%, which is quite effective. In our second session of an evaluation, we'll conduct a user evaluation in which we compare two conditions, which is with InstructPipe or without InstructPipe, or in the without InstructPipe condition, we call it visual blocks condition. And we measured, we have three kind of quantitative metrics. One is Nasha DRX. We also have time consumption and the number of user interactions, followed by post study interviews to understand their qualitative experience. So this is a demographic distribution. Well, this is also the criterion on how we select users. That is, we select people who has lower programming experience or ML skills because we consider that as our target users. And here's the result. As you can see that our system, the InstructPipe, can significantly reduce users' perceived workload and also reduce users' number of the time and number of user interactions in a given task. So all these quantitative results shows that InstructPipe can effectively reduce users' workload. And this sentence, or when participant further shows that what does it mean and what kind of practical benefits our system brings by reduced users' workload. For example, this person says that I have a lot of ideas, but my challenge is how to translate idea into technical words and see a prototype. I think that this app expedited me in that process a lot. So this person really likes the features because it can help them in their conceptual prototyping process. So now we introduce our system. And in summary, our system InstructPipe is doing is that by transforming users' human instructions into visual programming pipelines. But of course, there's limitations. So if we go back to the previous NASA TOX results, we can see that our system sometimes failed to demonstrate that it can reduce users' mental workload. But why? So from our investigation, we found one very interesting phenomenon, that is sometimes user feel it's very difficult to prompt. So they will spend so many times on writing a prompt so that, okay, they want to make sure the AI is going to generate something good. So they spend a lot of time on writing this kind of text. And after a while, these kind of things that appear, that is the visual programming pipeline, which means that they need to switch their brain mode from the text-based thinking into the visual way thinking. And this kind of switch between different way to think about the problem will cause extra mental workload. And we encourage future work to investigate this problem. Other than that, we also encourage future work to investigate the problems to scale up our node library and also create the systems that can generate the nodes dynamically, and also to understand the long-term usefulness of such kind of AI assistants. To conclude this work, we create a system called InstructPipe which allows users to generate visual blocks pipelines with human instructions and LLM. Thank you for your attention.